This is the Lego robot using Q-learning, and it's got a small amount of expiration. This is the third trial. N0 is 10 on this one, so that's going to be 10 over 10 plus the step number for controlling epsilon. It's just at the beginning. At the beginning it has an 80% chance that falls off pretty rapidly. And right now it's still taking a lot of random moves though. So this robot has the ultrasonic sensor in the front and then just one touch sensor. The problem with the ultrasonic sensor is that if it's at too much of an acute angle to the walls, it actually doesn't see them, so it thinks it's a long way away from the wall, and that's actually messing up the Q table because it thinks it's far and then suddenly it bumps the wall. Here you can see the robot's Q table getting filled in. This is actually just half the Q table. This is the part of the Q table when the touch sensor is not activated. The other half of the table is not all that interesting, except for when it's up really close to the wall. Here you can see the raw output coming out of the Python program running through Visual Studio Code. You can actually see the entire Q table here. The bottom part is when the touch sensor is activated. Notice that the touch sensor is getting activated. If you look at the last line above where it says plotting heat map, that's actually when it thinks it's at the furthest distance. So the distance is discretized here to be from 0 to 4. And it should never be hitting when it's at a distance of 4, hitting the wall, but the ultrasonic sensor, again at a very acute angle, thinks that it's very far from the wall. It's not apparently able to detect the wall when it's at that high an angle. After just 1,000 steps, the robot, because of the false readings when it's close to the wall, is learned to just go around in a circle, at least when it's far, sensing that it's far from the wall. Usually with the other two trials and this small amount of exploration, it actually did learn to go forward, but this is after about 1,000 trials, so it may continue this pattern unless something happens to disrupt it. And here you can see the heat map being updated, and if you look at that dark blue square at the bottom, you can see that that's turn right, and it just keeps accruing more reward there. And it would seem the optimal would be to go forward when it was at distance 4 if the sensor was actually accurate, but that's actually at about a 1.1, so it's a light blue. It's the next most preferred action, so it might be better to use something like a soft max action selection here rather than epsilon greeting.